Good evening, everybody, and my name is Anton. I'm going to talk about Ktor today. Just a little bit about me. This is me. You can follow me on Twitter. I don't spam that much, but sometimes try to post interesting things. I work remotely at JetBrains as a developer advocate, and I'm located in Estonia, in Tallinn. Kind of on the very north from you, from Israel. You know, if you fly 6 hours straight to north, you get to Tallinn, or something like that. I don't remember how much you have to fly. I have been once to Tel Aviv in 2012, I think. So yes, that's me, and we are going to talk about Ktor. So Ktor is a kind of a toolkit for building connected applications. We refer to it as a toolkit because it actually consists of two parts, a client and a server. So you can build services with Ktor in Kotlin, and you can build clients. So you can connect, your applications somewhere to some other service by using this library, which is provided by Ktor HTTP client. And that HTTP client is actually multi-platform. So you can build applications with that on JVM, but also you can use that library in your JavaScript applications as well as in native applications. Even if you compile something with LLVM, then HTTP client from Ktor is also capable of working there. Mostly it's because of the focus on multi-platform for Kotlin for mobile development. So you can use Kotlin for building applications both for Android and iOS. And on that iOS, you might need some HTTP client, and Ktor can be used for both, for Android and for iOS. But today we are focusing on server-side development. And if you come to the page of Ktor, Ktor.io, you will actually see the code snippet that basically represents what it does, right? You can read and understand mostly what it is. If you don't know Kotlin, you can still comprehend that, hey, there is an embedded server based on Netty. It's going to start on port 8080, and it's going to respond on some endpoint with the hello world text, right? So there are many samples that you can learn from about Ktor. If you go to the learn page, there is a sample page, and you can see all kind of different samples with different features and what are the small things that Ktor provides. But usually the first question that people ask about Ktor is that how does it compare to Spring, for instance? I think you are all familiar with Spring framework, right, as Java developers. And if you think about Spring is kind of all-in-one. You can do everything with Spring. Basically, it's a collection of recipes. You enable some sort of small configuration snippet or add a dependency, and boom, you have implemented. Basically, you don't have to build almost anything yourself. You just glue the components together, and you kind of have this feature implemented that you need. This is very productive, in fact. And sometimes people say that Spring is big and complex. I say that Spring is comfortable and productive. Ktor is kind of a microservice, micro framework, I would say. You start with the main method, you enable feature by feature, like there is almost no out-of-the-box functionality when you start Ktor. You have to kind of implement everything yourself almost. Like it's just that the framework provides some of the integrations that you could use them a bit, in a more comfortable fashion. But we are going to start with a small demo, in fact. Instead of looking at the documentation or the slides, I don't have slides today. We are going to look at the code a lot. So I have even a samples project open, but let's start from scratch. It's more fun. So In IntelliJ, we have a plugin. Obviously, it's called Ktor plugin. And it provides a wizard first, like the plugin itself provides a wizard and a few inspections. We're going to develop that plugin further so that it could provide even more inspections and all kind of insights in your application. It will be better integrated within IntelliJ for web development and so on. But let's do a small demo. I don't know if I have this project yet, but okay. And when you are building your first project here, you can choose the name, the build system, of course, the website, which is going to be reversed for the package name, obviously the version of Ktor, and then you have a few interesting options. Normally, you just keep them as default, but if you prefer to run, let's say, on some other engine, which is like a built-in engine in Ktor, it can be Jetty, it can be Netty, it can be CIO, which stands for coroutines IO. It's rather experimental, but it's fully asynchronous, and we are experimenting with that to kind of have it as a test bed for coroutines. You know, we have a library team that builds coroutines for Ktor, for Kotlin, and then Ktor team consumes that library and builds their own engine in Ktor. And you can use a Tomcat, obviously. So by default, we suggest to use Netty because it's the most performant and most stable one. But if you want to experiment, you're free to choose. Okay, we keep Netty. And then there is an option for configuration. So in fact, you can do everything in code. And you probably wouldn't need to do that to externalize any of your configuration if you just build a small microservice or small RESTful API or anything like that. But if you want some flexibility, you may choose the Kotlin file, and then you will have this configuration file, external configuration file, application.conf is the name by default. You can override that. And then in that configuration file, you will have the opportunity to, to do some custom configuration, for instance, if you build something in your application, or there are some default structure that is, expected by Ktor. Let's start with code by default. And the last checkbox here is kind of configuring the wizard to generate samples for you. So if you are not familiar with Ktor, keep this checkbox here, start the project, create the project with, all kind of interesting features that you like. In the next screen, you will see that. And demo 2. And the code will be generated for you, and then you will be able to learn from the sample, from the sample generated code, how to use Ktor and different kinds of features, what they can do for you. So let's start with that. Let's start with very simple example here. So one of the things when the application, just starts as a skeleton from the main method, the very next thing that you want to have is the ability to configure endpoints. And that feature in Ktor is called routing. So if we basically start adding any other feature, it will most likely say that, hey, this feature depends on routing. All kind of content negotiations, manipulating headers, and so on. They all will ask like, hey, please add routing as well. So we are going to add routing. And well, just for fun, let's add HTML DSL as well. So there's like different ways to respond to create responses. So you can send the text files, you can use server-side rendering, you can use Websockets. One of the template engines that we have is the DSL for HTML in Kotlin, and that's pretty interesting one. So let's build the application, and to start, I hope when the screen sharing is on, the IntelliJ will not be fighting for the resources on the machine. It looks like I have a new Mac. It's like for the first day, so it's the first time I'm doing a presentation from this machine, and I really hope it will not be conflicting on the resources between Zoom and IntelliJ. But it looks like it works. Okay, so the project is imported, and what do we see here? So in Gradle, we see, okay, yeah. The interesting part is the part with dependencies, right? I hope it's visible. And normally, when you don't select any features at all, what you will get is the server core, the Netty engine, and the logback library, and that's it. But since we added a few features, they added the HTML feature and HTML builder, and I think that's it. We didn't actually add much of the external features here. Okay, let's go to the sources. So as I said, the configuration as code doesn't include generating a Håkon configuration file, so we don't have that here yet. So everything we need to start the server is this embedded server method invocation that returns an instance of the engine, and we just say start. That's it. It will start the service on port 8080 with Netty, and it will have a few interesting things inside. So that's the simple example here. Routing, and that's the routing DSL built into Ktor. So inside that routing function, we can define all our endpoints, or even not just HTTP endpoints, maybe WebSocket endpoint, anything like that. And it's going to respond the text, right, below. Nothing too complicated. Let's go back. We have configure templating method. And we see another routing block. So actually you can extract those blocks in different methods to logically structure your application and to logically kind of compose different groups of those routes. Because if you put everything in one block, well, you might end up with a very long, very fuzzy, not understandable code where you have just plain pages, multiple pages of code, and it will be hard to maintain. But just extracting into separate methods, that would be totally okay. And it's up to you how you group them. We don't impose any requirements on that. They can be just functions. They can be extracted into different packages. Doesn't matter. In this example, we can see an endpoint that is responding in HTML DSL path, and the call here is an implicit variable inside that block that belongs to the pipeline. So we are calling back. It's basically a callback for us, right? To this call variable. Hey, respond with the HTML, and we are going to compose the HTML inside that block. Those are all valid Kotlin invocations. Basically, this HTML library consists of different functions that correspond to HTML tags. And what they do, they just create a document out of the invocations, and that's just a simple DSL. What is interesting here is that you can not just structure the blocks from those functions, but you can also use different functions and intermix them, or any other language constructs. So for instance, in here, I have a for loop to generate a list items. Very simple. If you're familiar with React, right, this is like something very similar to the server-side rendering. You would have those how you call them, JSL or JMX. I don't remember exactly.
JSP.
JS6.
No, not GSPs. No, okay. It actually looks
JS6.
like GSPs as well if we go back 20 years. Okay. So we can start the application, but I think you trust me that it is generated project. If I start, it will respond with whatever is written here. So we will not waste time. Let's generate another example, but with Håkon. So I'm going to do all the same. So demo 3 instead, but I will choose Håkon file. Next, and I'm not going to even add any features because I'm not interested in that right now. I just want to show you the configuration file. So that's the very minimal configuration file, and this is how it looks like. And the interesting part here, basically it consists of 2 blocks. There is not that much you can add. You can add a development variable, for instance, development, and set it to true in case you want hot reloading. So if you change the code and you recompile, there will be a new version of the class file generated, and then Ktor can detect that that file is changed, the timestamp for the class file is changed, and it will reload the modules, right? So that's okay. That's probably the single thing that I remember you can add here. The first block is pretty obvious. It's not probably obvious why you have 2 ports in here, but this is because the notation in Håkon didn't include like a way to set a default value for any attribute. In here, we have a default like written out, hard-coded in text 8080, and then you can override in case if an environment variable port is defined, is going to override the default value. I talked to the team that, hey, we could actually make it simpler maybe and have some other notation, something like this. Like if you define a variable, let's have such syntax, or maybe even like this. But it's not implemented. I hope they will take a look a bit later, and maybe one day we'll have some simpler syntax to define the default values here. The next block, the application block, basically lists the modules that you have in your application. And modules in Ktor are functions. So like the extension function that we will see in a moment, that's the entry point to a single module. And your application may have multiple modules enabled, depending on which configuration you want to start. So for instance, you implemented like a single application that includes multiple functionalities. Let's say we are building some sort of a car sharing service or something like Uber. We are building a new Uber clone. And then the functionality for maps and for interacting with the services, it will be all the same, but maybe your driver needs one functionality and your rider would need another functionality. So you can actually move this functionality into different functions, into different modules. And depending on which instance of the application you want to start, you can use the configuration file to list the appropriate modules which should be started when you start the application. Okay, so what's the module here? This is the single function. I can just even remove it here so that it will be cleaner. So that's the extension function for the application. In case you are not familiar with extension functions, maybe it's one of the features in Kotlin language that we can add a function to the existing type, and whatever is happening inside the body of this new function belongs or has the access or is happening in the context of that type that we are extending. So inside this module functions, when I type this will be of type application, right? So it is the application, and I will have all access to this application methods, functions, fields, and so on. All right, so this is a module, and we just configure routing here. This is also the extension function. We can actually inline it and move it back. And now we have routing inside our module function as is, like as if you started from, from the beginning. So basically, if I wanted to have two different functions, two different modules, let's say a driver, the same, right? And then maybe I would like to have either a different module like this, driver, or I can list, if I want to start all the modules, I can list the different functions with a comma in a single list. And then, it depends on your use case. How do you want to start the application, which modules you want to start, and so on. You can just have a custom set of definitions. All right, those are two simple examples. Let's move on to the features. What are the features? Features are like plugins. So if you go to documentation and you find developing application chapters, and there is a list of features that are provided out of the box. And it's basically those that are maintained by Ktor team. In fact, the community is developing constantly their own features, like for every little thing, just for reusing the code. Sometimes someone wants to connect to Kafka cluster somehow, in a special manner. They develop their own feature so they can reuse this way of connecting to Kafka in different applications. So it provides, let's say, what are the interesting features? I think one of the features that is the most popular one is the Websockets feature. Let's see how it works. Something like this. So if I want to enable a feature, I need to include a dependency, of course, if that's an external feature, doesn't belong to the core of the server, say HTML DSL that we used. It's actually an external library, and then there is a feature that integrates the library into the framework, so we could use it simply. And whenever you need to add a new feature to your application, you call install method and give it the name of the feature. Normally, it's the simplest way to install it, but sometimes you also have a configuration block right after the install method invocation. So you have two parameters. One is the type of the feature, and the other one is the configuration block for the specific feature. And for instance, what do we have here? We have default headers. What kind of default header you want to, let's say, I don't remember exactly what's the name of this. Okay, header. So it should be a header. So whatever, whenever you make a request to the application, it will respond depending on the logic in the routing method, but it will also add a default header, something like this, XY, for instance. So for whatever reason, if you need to always respond with the default header, it will be there. And the same way we have the other features. Let's say we have a, where was it? Content negotiation, for instance. Oh yeah, JSON. JSON is one of those most popular ones. So you install a content negotiation feature, it's not just about serialization. It will also handle this content negotiation process for you. If the client asks, the client will send what types of content it will be able to handle. And then this content negotiation feature will also take care of this negotiation process that, hey, the client can accept only JSON back. Let's find the kind of the handler that is able to produce JSON, right? And it will involve that handler automatically for you, so you don't have to do that. But also we can install like extra configuration, for instance, for JSON support. And for JSON, we have 3 different serializers like Jackson, JSON, and we have Kotlin serialization built in. So basically, this application with this feature installed, it will respond to the customer endpoint with the JSON text that will be serialized from this customer object. Right? So we are just responding with this class instance customer, but the client will see JSON. All right. So there's many other features, and I wouldn't
who is
go.
Anton, has a question. Who is calling the JSON function?
You mean this one?
The application.json function, line 10.
Application JSON function. It can be either part of the main module. So if you have main module configured in configuration file right here, and let's say inside the application structure, we would call JSON like this. So we install that route into our main application. Or in case we choose to have it as a separate module, not as a part of the main module, let's say main module is the app structure, we can configure it right here. So instead of app structure, we could have something like JSON. Sorry. What was it? It was JSON.kt, right? JSON.kt and then JSON. So it can be a standalone module in your application as well, in case you want to. It totally depends on your use case.
Okay.
So what else do we have? We have, I said we had a lot of features that are small, a little bit different from each other, that work with headers, like default headers, compressing headers, whatever else. Then we also have static support. For instance, you may mount any of the folders with the static block, and it will serve the static file. So this functionality is kind of built in. Locations feature is an interesting one. It's still under experimental API, but it would allow you to externalize those strings from the endpoint methods, from get method. So you basically start parameterizing your get methods with this parameter, and instead the path that you need to define for the endpoint will be defined in this locations annotation. So you kind of start getting this type safety in. It's not really like that, because you still have those strings in the annotations, but since you can define it as a class, it starts to work as a kind of content negotiation as well. So you may start serializing and deserializing kind of automatically. Okay, I actually want to build a small demo for you. And Ktor is often picked for its Websockets functionality. And I have this simple child application skeleton already here, and we may take a look how to build a WebSockets server that kind of implements a chat, very simple one, and the client maybe as well. I don't know how much time we actually reserve for those presentations. Like it depends how much I can show.
We have till 9:13.
Okay.
9:13. We have a 20.
Okay, I think I can make it in 20 minutes. So we have a project here with a server part and a client part. There are two separate projects. They're just grouped for for convenience here. They're kind of disconnected. They don't depend on each other. So we start with the server, and we have an empty application.kt here. We can see that the engine is Netty engine. So if it starts the application, it will call this module function because it's configured in my Hawkon configuration file. And what we can do now is install the Websockets feature, because it will be a WebSocket server. And we need a routing function as well. Oh, sorry, routing function. And we need a WebSockets endpoint. And it's provided by this extension, by this WebSockets feature. And we need to give it an endpoint name, of course, chat. So let's build an echo service first. So for instance, if a client will connect to this service, what will we do first? We can welcome this send. We can send some text to that client. Hey, welcome to our chat. Welcome to the chat, for instance. And then it's going to be just a simple echo service. So whatever frame we receive from the incoming queue, from the incoming channel, frame in incoming is a kind of implicit variable that is available inside this block. So maybe I'm just rushing ahead of myself. If you have a question why this is the way it is, you better stop me and ask, because I kind of assume that you know Kotlin.
Yeah, I have a different question. Maybe you can touch it as part of your explanation. Is that you previously you show that I can choose the engine. I can choose the engine A, B, C. So, and as far as I understand, the Jetty, Netty, CIO, and those has a different implementation for each one of them. So one of them is synchronous, one of them are asynchronous. One of them, like Netty, is a different beast. It's some both. But here you are showing some WebSocket. It's kind of implementation that it very depend in the implementation details of the engine itself. So in Ktor is in the way it's transparently for me as a user to write in a WebSocket server, client server, without knowing the engine under the hood. So I can change it to Netty, I can change it to Jetty, and it will work transparently without nothing.
Exactly. You don't have to know anything about that. So basically what is happening here is that the Ktor itself, the Ktor application itself, is going to run on top of Netty. So then you install this feature from Ktor, this module that handles WebSockets. How this interacts with the engine itself, I don't even know. But you can exchange that, and the API will be the same internally, right? So you don't have to adjust that module somehow depending on which engine you run.
Yeah, but let's assume that I want to write a kind of a driver. So let's assume that I want to write an answer to the user, and I need to read from some database his license to make sure that he's a valid user, to interact with. So I need to go with some JDBC driver or something, some other driver synchronously goes and read some stuff from the database, and then goes and write back to the WebSocket. So there is some interaction, and I'm going to write it in a synchronous fashion or asynchronous fashion, and this is the question. So me as part of the building block, as part of the flow, what kind of code I need to write to make the flow not break from the asynchronous fashions, and not me to making hard build an asynchronous fashion against the database or something like that.
Right. You will extract the database interacting code into a coroutine. We will see an example when we build a client.
Okay.
There will be a similar situation where we have a blocking call, and then we have to kind of take care of that. But let's get there.
Okay.
So this one is pretty simple. We get a frame from the incoming queue, and we need to check which frame is that. There is like different ways to do that. For instance, we can use the expression, the one expression for the frame, and then the IntelliJ can help with that. Well, you just ask to generate the remaining branches, and you handle it the way you want. Or we can just check this single frame like this with the save cast operator if that frame is of type text, and if it's not, just continue. So that's what the statement does. So if the save cast succeeds, we can go further. So what's next? We can ask read some bytes or text from that frame, and just respond back. So that's a simple echo server, I think. Let's do it like this. So and let's verify how it works. So run the application. Building the server, and meanwhile it's building, I can probably open the page. Okay, now it's running. I will connect from the web page here. So it's just, I have to put in my URL because it runs somewhere else, not on my machine, and then send a message. So we received hello there back. Right. Good. So it's the simple one. But what do we want? What do we need to do if we build a chat? First of all, we have many clients and like many concurrent clients. So we have to keep track of them, or keep track of the connections. And for that, I have a simple class connection that wraps a default WebSocket session. So that's the class in Ktor that handles, basically deals with WebSockets. Because if we go back to our example, we can see that inside this block, we have a variable this, which is of type default WebSocket server session. Right? This is the context where we work inside that block. So in my connection class, I'm going to just drop the session, and generate the name for the client whenever he connects. Right? The name will be generated automatically, user, and then some sort of a number. This is all we need just to keep track of the connections. And next one, just a second. And next one, where's my cursor? Okay, it's here. So we're going to change it a little bit. So what we need a collection where we are going to keep all those connections. So I have a live template for that in order not to type too much. So it's just the synchronized set, right, where we are going to store all the incoming connections. The next one is so we have to initialize the current connection. When a new client connects to our service, we are going to instantiate that connection with the current session. and put this new connection into our set of connections. So connections plus connection. That's the overridden operator, specifically for collections. So we just add, instead of calling .add, we are calling this operator. And then inside a loop, we can do something like this. Frame in the incoming, whatever it comes from the incoming channel. Remember, we can do the trick with safecast operator. What was it? Frame. So we are going to check if that frame is something we can work with. Read the text. That's the message we are reading in, and then we need to send this message to all the clients that we have registered in our set of connections. So connections for each, and with every session, we are going to do this send method and going to instantiate the connection, I think, yeah, the connection name, so that, you know, if you send a message, I should be able to tell that, hey, that's the other user who is sending the message. So we need to kind of tell it to everybody. So that user has sent the message, right? And that's basically it. Almost. We need to handle the exceptions as well. So since any of those methods, like sending or reading the text, can actually throw an exception because the channel might be closed. So the correct way to do that would be something like this. Take this block into a try-catch family even. For instance, we can do just print out the message. And in the finally block, we should deregister our connection as well. So we're going to remove that connection from the connection set. Why doesn't it? Oh, yeah, of course. Yes. Okay, and we can say that it's, you know, print that the connection is closed. Okay, so I think this should work. It looks pretty simple. If you compare it to Java, you don't see much of a difference besides this kind of tricks like using the safecast operator or using the overridden operators, or I know, maybe something else. But normally you would write very similar code in Java as well. So let's start the service and see how it works. Maybe we are good with what we have. So connect. Welcome to the chat. We could actually respond with something like, hey, there are n users in the chat, for instance. Let's do that. So send welcome to the chat. There are connections size users online. Let's do it again. Connect. There are 0 users online. Interesting. It should be 1. Oh, because we didn't add it. Okay, let me correct myself. Because this message should be sent a little bit later, after we actually added this connection to. Now it's correct one, right? There are one users in mind. Now we can actually try to build the client in 5 minutes. Can we make it? Let's see. Oh, I stopped the application. Okay. So what do we need to use the client? In the build Gradle, we have a client built with coroutines. The client part, remember I was saying it's a multi-platform one. You can actually use this in different platforms, not just in JVM, but also in JavaScript and native. And also we are using the client Websockets here. So just 2 libraries. So let's build a client. Vol client, HTTP client. What do we need here? It's going to be a WebSockets. We're going to use the WebSockets feature. We don't need to configure anything for that. And just a single block. Okay, and then of course, at the end, we are going to say that this client should be closed. That's the very end. But now we are going to implement the very interesting part of that. So going to register a new WebSocket. And there are multiple methods. If we look at the auto-completion, there are multiple methods. And in this case, we are going to just specify that we need to make requests, get requests. We need to connect to some specific host and port and to some specific path as well. And inside the block of code that follows the method, we will implement our business logic. So the method is a get method. And we need host. Was it host? Yes, host. It's going to be a local host, but it's actually local host by default, if I remember correctly. Yes. So we don't need to define that because the values there by default. We just say that we need 8080 because the default port is 0, I think, and the path, of course, path. The path is /chat. Okay, and now for accessing the client, we actually, oh yeah, you can see it's kind of currently underlined with red. It means that it's actually a suspending method. So it's a suspending method and it needs to be executed within the appropriate context. So if I hit Alt Enter, it will either tell me, yes, it will tell me that main method should be suspended, or I can choose to actually run it in a run blocking method like this, which is the one, my preferred way to do this. And now in a loop, what we need to do, we need to send the messages and receive the messages. So while true, and we need to, let's say, receive the messages, incoming. So remember the incoming channel, we can receive a frame or the message. It will be incoming message, incoming, yes, message. And then we can check again with the save cast operator how to, if it's a text message or anything else. And then we can just print it. So print line, incoming message, get, no, read text. That's it. That's the first part, right? But then we need to send the messages and we need some input for those messages as well. For instance, if it's just the client-side application, we are going to read line and then send this message. So if it's a if it's not null, for instance, but we are not going to check even for that. So read line, no, we're gonna send it like this, read line. So you see the problem here. It might be null. So we have to check for it. Or if not null, like this. So the question was before, like, what happens if we are using blocking calls within the same context that should not be blocking? In fact, we can extract those pieces into standalone coroutines and launch them kind of one after another, and they will run concurrently on the same thread, and they will not be blocking the thread. So whenever a blocking operation happens, it will basically give a way for the other coroutine to run. So let's do that. Launch. Like this. Let's move this block inside. And in fact, we are going to run that forever. And it's going to represent the job. Basically, we can then, let's say, cancel the coroutine at some point if we are not interested in receiving the messages anymore. So those are incoming job, for instance. Job. I'm still getting used to the new keyboard, sorry. And the other coroutine can be also like currently launch. Launch. Like this. And then extract into a variable, for instance, outgoing. Yeah.
Anton, you have a question regarding the mechanism. You succeed to do it because you are using the CIO implementation. This is the reason? Or it's independent? I can choose a different engine, but
that's
still
independent. That's independent still. Even if I had some other engine. No, wait. Here I don't have any engine for the server. It's just a client application.
Yeah, I mean client engine.
Oh yeah, yes. But CIO is there because it's multi-platform.
I see.
You wouldn't use Jetty or Tomcat if you want to implement the client with JavaScript, for instance.
I see, because it's a multi. I see. Okay.
One day, we hope that the Ktor and CIO engine can be multi-platform as well. So all is left here is we need to kind of join on the outgoing job to basically pause and let those coroutines to run further while we are waiting for it. So basically, we can implement the logic, for instance, if the client disconnects, or if we type exit, for instance, we can check if the input from the read line is exit, then we stop, we exit the coroutine, and then we reach to this join method and continue from there. And then the incoming job would be next to cancel and join, for instance, like this. I'm not going to complete this example, but you get the idea, right? I hope so. So basically, what happens when we run this code, it will start instantiate the client with WebSockets inside the run blocking method. Inside this client WebSocket invocation, it will launch two coroutines that will be concurrently receiving and sending messages depending on, if we want to type something, then this coroutine will not block the incoming messages. And it's all in the same, block of code that you don't have to kind of spawn new threads, for instance. It will all still be on the same thread. So yeah, that's the simple demo. In fact, you can find a lot of interesting examples somewhere in our GitHub. I will point you at those samples. So that was a list of different samples in our documentation. But actually, if you go to GitHub, github.com/ktor.io, you can find a samples project, which is a little bit different one. And in the generic samples, I think there is one very interesting implementation of small kind of video service that demonstrates how you can implement the feature that streams a video from a specific point in time. So I suggest very much to look at this example, for instance. It's a simple application. It also demonstrates how to use a database in Ktor, like this. So I think they are using exposed, or even, okay, even this example is not using the external database. They just mimic the database with a file. So, but anyway, there are a lot of interesting examples that you can learn from, and I hope you learned just something from my presentation as well. And it wasn't just time wasted.
No,
so thank you very much. If you have any questions, I can probably answer them.
Thank you. It was very interesting. I see two questions from the crowd. One is that regarding does it has any kind of DI like Spring? So this is the first question. And
okay, that's a very good one.
Yeah, you can start with that one. And
okay, in Ktor, no, we don't have a built-in functionality, so it's just an HTTP and some kind of skeleton support for your HTTP, working with headers and so on. But there are dependency injection frameworks in Kotlin, like Kotlin or Coin. Let me show you that. Kotlin DI. So Coin is the Kotlin dependency injection framework. That's the one. Or another one is Kotlin. This one. So these are two most popular ones. So you can use that with Ktor.
Yeah. Okay. Now, a second question I see here is regarding how do you test Ktor apps? If it's a kind of framework specifically for Ktor, or you're using some Kotlin-based testing framework, like in Kotlin, not related to any Ktor stuff.
Okay. Yeah, like you normally would write your tests with JUnit, right? But Ktor does provide some extensions. So where is my sample project? This one I can show you. There is a simple example where you have like a with test application, and you provide that application, and then you say, okay, I want to make a request, a GET request to that specific endpoint, and then you assert whatever comes from there.
Yeah, great.
Just this kind of basic support.
Okay, great. So I have a question regarding what you mentioned previously about Spring Grew, and does. It seems like a lot of ideas comes from different implementation, like Spring, like you mentioned. So if you're probably familiar, what the drawbacks / maybe to say when I need to take Ktor as an alternative because it has better than X for Y. So what is X and what is the Y?
No.
Or it's not.
Ktor is the #2 framework, as far as we know. Like as far as we know about the stats and different surveys, is the #2 framework, or the second choice of the frameworks that people pick for their project. The first one is obviously Spring.
Yeah.
And why Spring? Because it's battle proven. It has all the features. The industry know how to use Spring, and Spring even has Kotlin support since 5.0. They added a lot of extensions to use the framework APIs conveniently with Kotlin, and it's even improving even more. They have coroutines support. So Spring Boot 2.5 is coming out, I think, next month, and they will update all the Kotlin libraries that they are working with. So if I want to choose Ktor instead of Spring, I don't think I have a lot of arguments like for that, even myself, like because I like Spring actually. But if I want like a Kotlin native framework, maybe that's one reason. Like maybe I don't want to have this Java package or let's say Java luggage with all the infrastructure that I bring into my project. The second part is why people choose Ktor is that they want to have control over what's inside the application. So that's an argument for choosing a micro framework, right? I don't want Spring to do stuff for me. I want to do it myself. That's the argument. And the third argument probably for me would be that again, it's related to this control argument that I can control it myself. But then even in this example that I was showing, you see, I was kind of using coroutines directly. So it's probably a matter of taste, how you compose your applications. Like, hey, I want this library and I know how to configure that, and I want that library and so on. So you compose your application in the way you like, and you structure the way you like. And with Spring, you don't have this kind of control, or kind of you don't feel it maybe. And that's why people are choosing Ktor over Spring sometimes.
I see here from the crowd, Mark said maybe the size of the resulting artifact, maybe because a Spring, it's a big, I don't want to say it's a monolith, but it's a kind of very beast, and the Ktor is maybe more concise.
I think it's a kind of a valid argument, but if you know Spring well, you can actually strip down a lot. And if you start using Spring in a modular fashion, even let's say you are not using Spring Boot, which is a monolith because it kind of brings all the dependencies, but it solves the jar hell for you, right? So you say, hey, I want a web starter and Spring data, and then you don't care about versions of the dependencies, and everything is laid out for you. When you do it by hand, you add those dependencies by hand and you specify the version. Like as long as your application is not too big, it will not be a problem, maybe, until you start upgrading them, right? But if your application depends on 100 different other dependencies, maybe, highly likely, I would say, that you will have this problem with dependencies and managing the versions. So Spring actually does a very good job there. But if you are using Spring in a modular fashion, like Spring Framework directly, not with Spring Boot, then I think it's possible to strip down the total size of your artifact quite a bit, and it will probably not be very different, a couple of megabytes.
I see. I see another question from the crowd is regarding a comparison to Vertex, because Vertex it's a kind of another different, it's kind of abstraction to different engines. So do you familiar with kind of and a kind of a comparison?
It's very hard to compare it for me because I haven't used, I know general things about Vertex and I have played with it. They were actually the first to implement Kotlin support properly with coroutines. So it's also a very popular framework among Kotlin developers. I don't think I can compare them, like to say what is different and what is better.
Yeah.
To me, they are quite similar, and now the difference is that Vertex is maintained by Eclipse Foundation, and Ktor is maintained by JetBrains.
Yeah.
And why we started the project was actually, in first place, it was kind of an experimental project to try coroutines and try different libraries, and it was kind of a test bed. But it started to gain popularity. People started to adopt it. We started to build internal services, so that space product, for instance, is built from ground up in Ktor. And until last year, I think we only had 2 developers working on Ktor. So we actually extended the team, and we decided to make it a proper product with proper support. Now it's a team of 10, I think, something like that, who's working on it. So it's a proper standalone project, and we kind of aiming for stability, aiming for performance, because until now we were not actually paying attention to performance that much in terms of benchmarking, for instance. We know it's performant, it's pretty performant, but it's an empirical knowledge. We know that that project is doing well and they are happy with the performance, but we didn't have any benchmark data. Now the team will be focusing on that as well.
I see. Another question regarding the one of the biggest features is going to be as part of the JDK is Project Loom, regarding the coroutines built inside the JVM. So I believe there is a lot of we should call some kind of let's call it a kind of collision. Maybe the collision is not the correct word, but
yeah, I know the question.
Very complex,
on almost every meetup, people ask this question, so it's not a surprise. So first of all, Loom was promised in Java 17, if I remember correctly, and it seems it's not going to happen because like before actually getting to Java 17, we had to get experimental version of Loom in Java 16, and didn't happen, right? So we are waiting for another 3.5 years until the next LTA, until we get Loom in an LTA version. Maybe we will get it earlier in some non-LTA releases, but LTS releases, but it's still a promise. Regarding Kotlin coroutines, it's basically a library feature for Kotlin, right? There is a single language support keyword like suspend in there, but basically coroutines is a library. And regarding that, I think what is going to happen is the team is going to work on the experimental version of coroutines based on Loom. So Loom will be kind of a backbone of coroutines in that version. But I don't know exactly. It's something that people are going to experiment with, see if it actually works, and so on. It will take time.
I see. Okay, great. So another question from the crowd, someone?
So basically with Loom, we can just currently, we cannot predict what will happen. We can improvise or
Yeah. I believe if someone going to take Ktor as a microservice or any kind of infrastructure to his company, and one of the biggest changes in JVM is going to be I believe in 1 year from now. So it's going to be a kind of key consideration as part of the, to choose Ktor or not. But if it's a 2 or 3 years from now, so it's not an issue. What I believe that people search in this specific question, and I see it as a hidden debate in the net, is that people want to know that even if because the Ktor is an abstraction, so once JVM will go with a different threading model, whatever they choose under the hood, Ktor it's abstract. I don't want to know what happened underneath.
Well, I think the argument between like why should I choose Ktor, it should be vice versa. Why should I not choose Spring today?
Yeah, yeah, yeah.
I think Spring, like maybe more than 50% of the projects are using Spring today, and if you're picking some other framework, you should answer the question, why are you not picking Spring?
Yeah, I see. I see another question regarding GraalVM. Do you know something regarding
Yes.
Ktor and GraalVM? So it's worked today?
Yes.
It's something production ready already?
Yes, it works with GraalVM. I have seen projects compiling to native image. So I think the question is rather if Ktor is capable of working with GraalVM native image, not just GraalVM. The answer is yes.
I see. Okay, great. So someone for the last one? I don't see
the very last one.
The very last one. Okay, so I see no new questions. So I want to thank you, Anton, about the time and about the session. Like we said previously, we are going to upload it to our YouTube channel. And if someone wants to reach you, we will put your private, your home phone. What do you prefer? Your cell phone?
Twitter handle is good enough.
Okay, so Twitter handle. So anyone that want to explore more about this specific session, go ahead. We will put an Anton Twitter, and you can go and use it. And thank you very much for everyone to be here. It was glad to host Anton. And Anton, thank you for everything that you are doing as part of your community.
Thank you. Thank you very much. Thanks for having me, and have fun and play with Ktor and try to answer the question, why are you picking something else than Spring?
Okay, great. Thank you very much. Good night.
Good night.